me, Mario!
During a 2013 speedrun of Super Mario, Mario suddenly warped through the ceiling.
What the?
Did you get invisible walls?
What?
Please say you got invisible.
No, that was the craziest thing I've ever seen, though.
This was a game-changing shortcut, shaving off valuable seconds, but nobody could recreate it. People tried everything. Someone used an emulator to match the exact controls the player used. There was a $1,000 bounty to recreate the glitch. But after 10 years, it hasn't happened again. Zoom out. So we're surrounded by this invisible, radioactive space dust. It's raining down around you all the time. It's hitting you right now. You just can't see it. These are cosmic rays. They're subatomic particles that get spit out by our sun, and we think supernovas and black holes, and I swear this relates to Mario. You're seeing them visualized as they streak through fog in a machine called a cloud chamber. I remember seeing one of these at a science museum as a kid and being unnerved by the knowledge that these rays were surrounding me and had always surrounded me without me ever knowing. But it gets weirder. These particles from space affect our machines. When a cosmic ray hits a computer's transistor in just the right spot, it can trigger what's called a bit flip, changing a 1 to a 0. Most of the time we don't notice, but when just the right bit is flipped, the results can be disastrous. Last October, a JetBlue flight plummeted 10 stories in the air over the Gulf of Mexico, injuring passengers and resulting in a diverted landing. The flight log suggested a bit flip as the culprit. During an election in Belgium, a bit flip skewed the results so dramatically it necessitated a recount. So we simulated another playthrough of the Mario speedrun, only this time we started switching bits. And when one particular bit was flipped from a 1 to a 0, it changed Mario's vertical position, levitating him just above the ceiling. It's hard to tease apart cosmic rays from other forms of radiation. We'll probably never close the case, but space dust will always be a culprit. There are wavelengths from the universe floating all around us, signals we can't see or hear or touch. Without seeing them, these signals interact with us. They interact with our bodies and our machines. They cause glitches and breakdowns and uncanny feelings. With the right camera, in a dark room, you can see them. With the right machine, under an empty sky, you can hear them. Hold still, and you might be able to feel them. Reality is full of ghosts. My favorite series of all time is about a cosmic dust, raining down from space, invisible to the naked eye. Except this dust is conscious. This is His Dark Materials by Phillip Pullman. It's been adapted a few times by now, and we'll use footage from those adaptations, but this is about the book, okay? It's always about the book. I'm annoying like that. Read books. The series takes place in a world almost like ours, but not quite. A girl named Lyra was orphaned and raised at Jordan College in Oxford. Our world shares one of those locations, but not the other. Lyra's world is on the brink of change, transitioning from the warm glow of naphtha lamps to the harsher and brighter anbaric lights. We can infer the meaning of these words. The scholars at Jordan whisper about the discovery of a new subatomic particle. They learned of its existence the same way we know about dark matter, which is through its absence, the shadow of where it should be. But unlike dark matter, everything changed when dust was photographed. The particles fell down from the sky in golden streams, like dust motes floating on a sunbeam, but they didn't fall equally. They gathered around people, everyone glowing with an aura. Everyone, that is, except children. As you might expect, this causes quite a stir. Dust catches the attention of the church in this world, and they deem it to be original sin, a knowledge that infects us. But we never would have known if we hadn't caught it on film. You can't photograph dust with just any old camera. It takes a special type of emulsion. But film photography is a chemical process. Change the chemicals, and instead of capturing light, you can capture invisible things. That's true in our world, too. Like the scholars at Jordan, ever since the invention of the camera, we've been using it to look for the intangible. And, like the scholars at Jordan, we've found it. Just not in the ways we've expected. I think it's easy to overlook the magic that the basic film camera is already performing. It's already a tool to interact with reality. We've known for a long time that certain chemicals react to light, for example, silver, and we knew how to catch light in a box using a lens. So we learned that if we trapped light on top of the right chemicals, we could do something new. We could capture a record of it. That's what a film photograph is. It's a physical recording of the light, a footprint of the particles in that very moment in time. This is the earliest surviving photograph. It's called View from the Window at Le Gras, and I can't get over how it looks more like a dream or a thought than a photo. There's an even older preservation of light than the photograph of Le Gras, but we didn't take it. And we found it on accident. In the 60s, a pair of radio astronomers set out to measure the brightness of galaxies. They were using a hand-me-down telescope. It had been years since its last experiment, and it had sat idle ever since, home to dust and a family of pigeons. But when it comes to 20-foot radio telescopes, beggars can't be choosers. Before Arno Penzias and Robert Wilson could start measuring, they had to calibrate the telescope. So they pointed it at sources whose brightnesses we already knew in order to establish a baseline. But there was a problem with the readings. They all came back with this faint background hum. At first, they thought it was environmental, maybe coming from nearby New York City, but the static was constant, no matter which direction the telescope was aimed. They spent 9 months troubleshooting. They blamed the pigeons roosting inside. They removed their nests and spent days cleaning their droppings off of the machine. One by one, they eliminated every source of interference. Still, their measurements crackled with an unknown reading. But the telescope wasn't broken. It was picking up a signal we didn't know was there. The beginning of the universe was shrouded in fog. It was too hot for matter to form, so the light was trapped behind this jumbled sea of electrons. When things cooled down enough for the electrons to snap together, the light burst free in a flash. That same light has been traveling for nearly 14 billion years, stretching as the universe expands, from visible light into infrared and finally into microwave radiation. By the time it reaches us, it's no longer something that our eyes can see, but a radio telescope can. Penzias and Wilson picked up an echo of the beginning of the universe on their radio telescope, and they were able to translate it into the sound you've been hearing. But if you think of it as light, it's even more than an echo. It's a photograph of the Big Bang. There's something about the omnipresence of these signals, cosmic rays and the cosmic microwave background, that really unsettles me. It's like the universe is trying to reach out, showing up on all the machines it's able to, and we mistake it for interference. And I know that's a lot of meaning to ascribe to a subatomic particle, which is probably just doing what subatomic particles do, but you can't blame me, okay? I grew up on stories like this. In Pullman's world, the particles of dust are drawn to knowledge. The same way the particles gather around adults but not children, scholars notice that the particles are drawn to certain objects more than others. A piece of ivory doesn't react, but a carved ivory chess piece does. A chunk of wood sits inertly, but a wooden ruler glows with dust. The more workmanship and knowledge surrounding the object, the more the particles gather. We've seen something similar before. In our world, in the 40s, a couple from the Soviet Union stumbled upon what they thought might have been evidence of an invisible life force, and it looked a whole lot like dust. The Kirlians placed film on top of a conductive plate, attached it to a high-voltage power source, and put objects on top. Instead of light, electricity acted as the exposure, and the results were strange. Living things seemed to glow more than others. The aura of a leaf left to wither on the plate grew dimmer over time. The Kirlians photographed their hands and said the glow changed with their emotions, and most famously, they photographed a leaf that had been cut in half, but its outline remained whole, glowing with the ghost of the missing piece. Today, we understand what was happening. If you've ever used one of those little plasma globe toys, you've actually already done this experiment. When you touch the globe and the electricity gathers around your fingertips, your hand is acting as a conductor, and certain materials are better conductors than others. Moisture conducts better than metal, skin better than coins, a fresh leaf better than a dry one. As for the cut leaf, nobody's been able to replicate it. It was probably either a double exposure or moisture left behind on the plate. But the thing is, we're better conductors when we're emotional because we sweat. It's possible different emotions really did register differently in Kirlian photography, the same way mood rings respond to body temperature, which is affected by our nervous system, which is affected by our mood. The Kirlians weren't photographing auras, but they were recording something real. The way matter and electricity influence one another, the way we interact with our tools. And once again, the way a machine built to react to one thing ends up becoming a translator for something else. In His Dark Materials, that translation is literal. Back in our fictional Oxford, Lyra is given a device called an alethiometer. It looks like a compass made of solid gold, only instead of the cardinal directions, the alethiometer is lined with symbols. The tool is rare. Only a few are left in existence. The knowledge for how to make them has been lost, and they take decades to learn how to read. But they're a way of asking the universe a question. The process requires a relationship between the user and the tool. You point the 3 dials of the alethiometer toward different symbols to ask a question, while holding that same question in your mind. In response, the needle begins to move, spinning and settling onto a pattern of symbols that form an answer. Lyra is able to read the alethiometer intuitively. She describes it as making her mind go blank. Over time, she gets a sense of a personality behind the answers. They have a mood, but it's not any single spirit she's communicating with. She's talking to dust. Dust is omnipresent in Pullman's world. It's everywhere. It knows everything. It always tells the truth. But crucially to the series, dust is physical. It's my favorite thing about the magic in Pullman's world. It's tangible. It can be measured. The same way dust was photographed using a special type of film emulsion, the needle of the alethiometer is coated with an alloy that reacts to the particles. It makes me feel like we really could communicate with the universe someday, if we could just find the right tool. There are plenty of instruments for divination in our world. It's just a question of what they're actually measuring. The Ouija board is a familiar example. If you've ever used one, the planchette feels like it's moving on its own. Believers say this is spirits causing the motion, either directly or using the bodies of those at the table. I bought a 100-year-old Ouija board for the purposes of this video, and I hosted a seance with some friends. The instructions on the board mirrored the rules of the alethiometer. Printed on the back, it says, "It is important that the persons present should concentrate their minds upon the matter in question and avoid other topics. Have no one at the table who will not sit seriously and respectfully. If you use it in a frivolous manner, you naturally get undeveloped influences around you." I hold 2 conflicting realities in my mind when it comes to the supernatural. The seance was creepy. My hair stood on end. We heard scratching noises in the crawl space. I've had bad dreams in this house. The board warned us about a negative presence. It was repeatedly spelling out the word avoid. We were all adamant it wasn't us moving the planchette, and I believe my friends. I also believe in the ideomotor reflex. They've studied this. Where people are looking on the board predicts where the planchette will move next. We all make unconscious movements, and when you have a group of people, the movements add up. It's like an improv game. Meaning emerges collectively, 1 letter at a time. And I never know how to square that circle, because it feels possible, doesn't it? That something else could be coming through, that our minds contain the ability to connect with something beyond us, something too slippery to pin down in a lab, too ineffable to show up in a study, or maybe something some people can connect with and not others. It feels possible because if ghosts exist, we don't know what they're made of. And when we don't know the physical stuff that makes up what we're looking for, it leaves open the possibility that any tool might respond. Ted Sirius was a bellhop from Chicago who claimed he could photograph his thoughts using a Polaroid camera. His process was to roll up a paper tube, which he called a gizmo, and point it at the lens to focus his thoughts. When it felt right, he would gesture and capture the moment. And coming back to this idea of the right state of mind being necessary, this interaction between the universe and ourselves, he said he had to be drunk while he did this. When the Polaroids were developed, some were of his face. Others came out blank, either over or underexposed, in a way that never matched the lighting. But it was the third type of photo that caught everyone's attention. These were landscapes, buildings, thoughts. We never learned exactly how he did it. A few people said they saw him slipping a tiny lens into the tube. Trickery aside, I'm still struck by how these photos remind me of the first surviving photograph, a preservation of light that looks more like a memory. Photography became popular around the same time as spiritualism. It's loosely a religion, but the belief is this: life persists after death in the form of spirits, and spirits can be contacted. This was the era of mediums and seances and ectoplasm, and it's hard to tease apart what was actually happening because, to be clear, the field was ripe for scams. There were mediums producing ectoplasm from places where ectoplasm should never be produced. But there was also research happening, and it was happening very much in earnest. Science and ghosts weren't in contention like they are today. This was the dawn of electricity, a force which Michael Faraday said was upon the threshold of what man is permitted to know of this world. We were learning about radio waves and the telephone, voices traveling through space. Thomas Watson, who you have to thank in part for the telephone, consulted a medium to ask the spirits for advice in improving the machine. Spirit photography became a booming industry. Photographers claimed to specialize in capturing ghosts, promising families a chance to reconnect with their loved ones who had passed. In the words of American painter James Whistler, "Everyone knows there are certain chemicals that act only in darkness. Why should it not be the same with the spirits?" And why shouldn't it be? Because all we had to do was nudge the chemicals in one direction or another to be able to capture infrared light and ultraviolet light, to be able to see and to capture the intangible. The explosion of inventions around this era were all just harnessing previously intangible particles and waves. The only thing implausible about Ted Sirius photographing his thoughts was the tool he used. A Polaroid camera can't capture brainwaves, but using an MRI or an EEG, we can. Ghosts today remain a nebulous concept, and so modern ghost hunting tools run the gamut. EMF readers capture electromagnetic fields, EVP recordings are looking for sounds outside the normal hearing range. Even the Xbox Kinect has become a popular tool. That one maps a grid of infrared dots onto the room, and in an ultra-modern twist, relies on machine learning algorithms to catch any human-like shapes that might appear. If ghosts are real, we don't know if they can communicate via electromagnetic fields or with infrasound, but we do know those same frequencies can interact with us. You can engineer a house to be haunted. This is a collaboration between an architect and a psychologist. It's called Haunt. They built a small room and filled it with infrasound and magnetic fields, both of which are thought to cause feelings associated with hauntings. Sure enough, after about an hour inside the room, people described the sense of a presence. Chills, dizziness, even auditory hallucinations. It was a tiny study, but almost everybody reported some sort of disturbance. Our own houses can produce these frequencies naturally. Old wiring, radiators, pipes, the geology beneath the foundation, even the Earth's magnetic activity. Ghosts or no ghosts, the result is the same. The universe itself can haunt us. There are other worlds in his dark materials, representing other possible realities. The veil between them becomes thin in the Northern Lights. So thin that another world can be photographed beyond the curtains of light, using the same technology which photographs dust. The photos come back fuzzy, the hazy roofs of buildings and the golden domes of churches, like the view from the window at Le Gras, like a photograph of a thought. Lyra is able to travel to the other world in the Aurora, and eventually finds herself in our world, our Oxford, a world next door to her own. There, the alethiometer guides her toward a scholar named Mary, who's studying dark matter. Most of our universe is made up of forces we can't see. Matter, all the planets, the stars, the galaxies, us, we're all just a speck in the dark void of space. We know dark matter exists because of its absence. There has to be more mass than we're accounting for in order for gravity to work. There's a particle we're not able to observe. What tool do you use when you don't know what you're looking for? Where do you even begin? In one of my favorite scenes in his Dark Materials, Mary has found a way to talk to dark matter through her computer. With electrodes hooked up to her skull, she's been able to see it and interact with it. But now, she's built a program to communicate with it. She felt the hairs begin to stir on the back of her neck, and she became aware of the whole building around her. The corridors dark, the machines idling, various experiments running automatically, computers monitoring tests and recording the results, the air conditioning sampling and adjusting the humidity and the temperature, all the ducts and pipework and cabling that were the arteries and the nerves of the building, awake and alert, almost conscious, in fact. It was almost instantaneous. She felt as if she had stepped on a space that wasn't there. The answers lashed themselves across the right side of the screen, almost before she had finished. I wish so deeply for the tools in Pullman's universe, for the alethiometer, for Mary's computer, ways to translate the noise, and in doing so, to understand ourselves. Dust is only a name for what happens when matter begins to understand itself, Pullman writes. Matter loves matter. It seeks to know more about itself. Our universe is always speaking. It speaks in signals which show up in our periphery, streaking through the fog and bleeding through our telescopes. It flips bits and changes data. It alters how we feel. Sometimes its intrusion is grand and mysterious, but mostly it shows up in the mundane. The light from the Big Bang, that sound of the universe, you've grown up with it. You saw it on your television. You heard it on the radio. It lives between channels. A small part of that static is the cosmic microwave background radiation picked up by an antenna somewhere. The beginning of the universe, bookmarking the morning cartoons. I think it's telling that white noise belongs equal parts in horror and in sleep soundtracks. The lack of coherence is comforting. There's nothing for our brains to latch onto, no repeating pattern. And yet that same lack of coherence is what makes it dangerous. If we can't predict it, how can we possibly know it? The drone of the signal carries within it the possibility of its constants being disturbed, for something else to come through, a message, a voice. We stand at the edge of our universe in the dark. For all our tools, we can only see a few feet ahead. When we see shadows in the fog, we hope for ghosts, for a presence, because the alternative is too lonely to bear. We'd rather have a haunted universe than an indifferent one. With each new way of seeing new ghosts appear, signals caught by the edges of our devices that we don't yet understand, every new discovery promises answers. If we can just figure out the new rules with this new technology, maybe then we'll have a glimpse of the true nature of reality. But dust is tricky like that. There's only so much understanding it seems to allow. Every layer we peel back only raises more questions. The closer we look at the signal, the more complicated it becomes. Reality lurks a step ahead, forever waiting to be detected by a new machine. I'm picking up a mysterious signal. It says you watched this entire video, so you probably like to think and you enjoy independent media and you're trying to hold on to your attention span. But the signal says you might be frustrated with the state of the modern internet. You have to wade through a fog of garbage to find good content. You might dream about another world full of high-effort videos made by real people who are being paid fairly, and also the platform where it lives isn't evil, and also there are no ads. I'm not sure. The signal is fuzzy. But if that's accurate, I'm here to tell you that world exists. Creators already made that for you. Creators made a streaming service called Nebula. Creators like me keep telling you to come over to Nebula because it's better. It's better for us, and it's better for you. You'll find all my videos over there, except without ads and released early. Nebula is the first place I release my videos. This one went up last week over there. But it's not just my videos. It's a community of over 200 hand-picked creators, which is expanding every month. And it's not just our regular content. Creators also upload bonus videos, and most notably, there's a growing library of Nebula originals. Nebula was like, hey, what if we give artists the tools to make the stuff they dream about making but couldn't do on their own? And that's how you get media like Boomers and Scav, media that is so fresh and full of heart because it's not made by a team of executives in a trench coat, it's made by real people. Nebula is $2.50 a month when you sign up for the year using my QR code or the link in the description. $2.50 a month to support independent media and independent creators. My discount code also gives you 40% off a lifetime subscription if you're sold and want to support the mission. If you watched this video on Nebula, you even got a bonus message via an actual seance that I conducted in my home. I risked getting haunted for my Nebula subscribers because they're worth that to me. As always, a million thanks for being here. I appreciate you so much. Stay safe from the ghosts and the horrors of this world, and I will see you in the next video.